Hi everyone, good evening. Welcome back to the channel. Hope you had a blast over the weekend. Um, Belated happy Diwali for all the people who probably could not join us in the last session. Hope you had a safe and wonderful festival. Um, Let us continue our discussion with respect to the data science modules and how you need to prepare yourself for, let's say, an interview. Right? We are trying to give you all those tips and secrets that you have to learn with respect to cracking an interview. Now, as part of this, the series that we're conducting is trying to bring up all those important questions that you need to prepare, and how you have to try and answer these questions is something that we are learning here, right? And as part of this, we have brought in the resources also. Um, we have made these resources available, and we are constantly updating this. As part of this, one of the important resource that you will have to refer to is the mind map, which is placed on 360 Digit MG website. So let me walk you through with that, and we will also make the blogs, the series of questions that we are talking about. These questions are also made as part of the blogs. We will share the links as well for you to refer to these questions. But let me first walk you through with the mind map. Okay, let me launch, and this is how we basically go. So I will start with 360 Digit MG website. I'll log in here. I will launch the URL. Here you see mind map and learning resources, right? So both are very, very crucial for all the participants, all the people who are interested to get into the data science world. These resources are going to help you immensely in your preparations. So if I click on learning resources and scroll down, you will see interview questions module. You will see a digital book for your quick references. You will have mind map. We will have the periodicals, which gives you the latest of the informations. We have cheat sheets also being made available for you. If I go to the mind map, this is something which is readily available for you to access. You can click on learn more. This page opens up, and if you click on the drop down, you see the last one. You have a lot of content available. You might want to refer to this for your quick learning and referencing. And if you see this last option, this is the mind map, which is being made available. We are trying to create this more and more comprehensively. It gets constantly updated. Excuse me. So if you look at this, we are talking about the question and what are the points that you'll have to remember, and what kind of an answer is expected, what you should not do, and what is that you have to do in the interview, right? So these are the kind of content which is being made available for you. Refer to this particular link, and hope you will be excelling in your interviews. So the link is shared on the chat. You can just bookmark it and try to use it for preparation. Now let us wait for Mr. Nitin Mishra, sorry. And yeah, hi, good evening, everyone. And Nitin, please, you can take over and let's start our usual session.
Good evening, everybody. Excuse me. Good evening, everybody. Sorry for the couple of minutes delay there. Some net connectivity issues. I couldn't join immediately. Apologies for the same. So yeah, as Sharath was explaining about various resources that are already available, what we are adding by way of the interview preparation session, these half-an-hour capsules, 5 days a week, are all small increments to a huge amount of content that that we've already have created for you. So you'll have to take everything, anything and everything that is being provided is something that you need to take up. All right. So in the in the last class, we were doing machine learning, and we were discussing about the unsupervised learning is something that we had touched based upon, and we will now touch base upon supervised learning. And supervised learning also, we discussed briefly about the choice of models, that is with reference to why would Barney or Sharad choose a particular model, and what is the rationale you're going to do that. So what we'll do is we'll continue on that. The rationale or the reasoning behind it is that while fundamentals of statistics, fundamentals of exploratory data analysis, data pre-processing are essential, you are going to be tested on the machine learning models more in detail. All right. So I'll be getting into the depths of the same. All right. Now we are going to focus specifically on the hyperparameter tuning with reference to the various various supervised learning models that we have spoken today. All right. And then and then we'll also move to excuse me, I have a little bit of a bad throat, but luckily I'm an interviewer, so I won't be speaking much. I'll be expecting them to do the that way I'm a little safe today. So we'll do a couple of things at a high level. So yeah, I'll start with Sharath. So you've chosen tree-based models for your, you had chosen regression-based models for your project that you had mentioned. So I want you to elaborate on the choice of various hyperparameters, if any, and how did you, what are the experiments you have done to tune the model to improve the, accuracy as well as address the problem of overfit.
Yeah, thank you, Nitin. I think there are multiple questions in your single question. So we'll probably give your throat a rest, and we will try to break up these single question and try to discuss among ourselves on right, each phase of it. So the first point is, I have, yes, selected the regression-based algorithm. This is because the variable of the interest that I have to predict was fuel efficiency, which is a continuous value. So whenever I have a continuous value, obviously I will prefer doing regression, right? That's how machine learning works. So we'll have to go for regression-based techniques. Now, I did try multiple models. It's not that I have not tried multiple things and I have only applied with tree-based algorithms, but when I experimented with multiple regression-based algorithms, ultimately we figured out that the model which was giving us much flexibility and, of course, good accuracy was a tree-based algorithm. We tried to do the standard linear regression method. We did a little bit of hypertuning there. We did transformations. We tried to change the scale of the data from standardization, from normalization. Then we also tried offset variable. There are multiple things that we basically brought into the linear regression. Probably we can elaborate and discuss them in detail in a separate question. Maybe I'll try to elaborate that in a separate answer. But yes, linear regression, that was one method. Then the choice of the algorithms that I made was specifically to ensure that there is some kind of an explainability, because our client was coming from non-stats, non-mathematics, non-computers background. So we had to give that explainability so that they can also in turn explain the models to their customers. That was the first choice. So after regression-based algorithms, the best choice was obviously the tree-based algorithms. These shallow techniques, of course, as we always try and have this discussion that it's not an algorithm, it's a rule-based. methods and all that. So it's not a machine learning or it's a machine learning, whatever it is. But the tree-based algorithms were the best methods that we experimented. In order to bring up the best accuracy, we did use automation techniques. Grid search was basically tried, and we experimented close to 100 different variable tuning options to the grid search method. We could have tried more. It's not that only 100 is the limit, but given the time constraints, we were able to experiment on 100 different set of parameters. So each time I was changing the algorithm, it was one experiment. Likewise, we did 100 different experiments, and one of that was giving us the best result. And we set those parameters, and then we, as usual, the post model development series of things happen, and finally we gave the deployed model to the customer.
All right, Sharad, thank you. Thank you for the detailed answer. Sorry, my question was a little, what shall I say, loaded. It wasn't a very specific question, but yeah, you can expect audience to have not very clear questions also from the interviewers. All right, so Barney, over to you. Anything that you would like to add with reference to the choice of the hyperparameters, which was giving you? How does one actually, rather than randomly doing it, how does one go about choosing maybe this is suited for that? Any such tricks?
Yeah, sure, Nitin. Thank you so much for asking this question. And this question is extremely important. And the one keyword or one word that I would tell to any data scientist is experiment. Until and unless you experiment, you will not come to know on which algorithm works well on your data and what set of hyperparameters work well on your data. No one can tell without experimenting. And one way of experimenting is something which Sharath has already spoken about, which is grid search technique, in which for different hyperparameters, you give multiple options. For example, number of trees. You might want to run 50 trees, 100 trees, 150 trees. Depth, maximum depth can be 1, 2, 3, 4, 5, 6. It can go on and on. And in that way, there are a lot of hyperparameters within decision tree. As we've already told to the audience here, from next week onwards, we would take each algorithm and we'll delve deeper into that. So I would not get too much into that, into hyperparameters of a specific algorithm. Having said that, when you use grid search technique to experiment with various hyperparameters, it will try out all the permutations and combinations. Number of trees, 100, 200, 300, for example. And maximum depth is 2, 3, 4. Then it will try out 100 trees, maximum depth is 2. 100 trees, maximum depth 3. 100 trees, maximum depth 4. In that way, it will try out all the combinations. And it is usually time consuming, especially if your data is humongous. Training would take huge amount of time. Given that, people also use something called as random search technique, random search cross-validation, grid search cross-validation. In random search cross-validation, out of all the combinations, your technique would randomly pick a few settings, a few hyperparameter combinations, and then it will run and tell you that, hey, for this combination, we have got the best result. And there is also something called as Bayesian search technique. Within Bayesian search technique, one setting of hyperparameters is randomly chosen, and the next option is chosen in such a way that it increases the accuracy. So it is slightly intelligent than your grid search or than your random search cross-validation technique. We have something called as hyper-opt algorithm, hyperparameter optimization. That is also based on some calculus, derivatives, etc. It also has the intelligence built in. As opposed to trying all the experiments, it would randomly choose one, and then on top of that, the next settings that it would choose would be better than the previous setting. And this would go on and on. And one more thing that we have tried out on our project is Teapot, which is an auto ML technique. When you apply this technique, this algorithm will figure out what are the right set of algorithms, or it would experiment with various algorithms. And within each algorithm, it will look at the hyperparameters and it will try out all the permutations, combinations, and then it will throw at us one pipeline within which it will be clearly mentioned on what are the set of algorithms and what are the set of hyperparameters which give you the best result. Given the time constraint, if you say that run for 15 minutes, within 15 minutes, whatever are the experiments possible, it would complete and give you the best result. If you say run it for 6 hours, it would run for 6 hours. And then in these 6 hours, out of all the experiments performed, it will throw the best algorithm at us. So this is another thing that people might want to try out, given that customer wants the best result. Customer is least bothered about whether you write 1 line of code or 1,000 lines of code. So Teapot is one thing which will help you run probably 10, 12, 15 lines of code, job done. You would get the best algorithm as opposed to going after, all these experiments. So smarter way of dealing with the algorithms is auto ML way of dealing with that. Yeah. Thank you, Nitin.
Thank you, Bernie. So, like I said at the beginning, we'll be, moving at a high level of various aspects of machine learning entirely this week, and then we'll be going deeper into specifics. So basically, you can treat this as the MBBS program, and then we will go into cardiology and neurology, etc. in the next weekend. So continuing on that lines, we'll quickly talk about time series, and I'll leave the question open-ended because of my Sharat's complaint that I ask very big questions. So Barney, what can you tell us about time series vis-a-vis the projects that you have done? And any interesting insights that you have had from time series. Over to you, Barney. First.
Yeah. So when it comes to time series, Nitin, there are multiple options that one has to figure out. One is a client a new client who is outsourcing the project for the first time? Are the processes to capture the data intelligently devised? Are they mature enough? Are people automatically capturing the data, or is it a manual way of capturing the data? Are you doing a project for a client in a country where there is too much of volatility? Or are you doing projects for customers in countries where the processes are well set up for that industry? So whole lot of things go into picture, not just time series, for any other algorithm as well, but for time series it will be even more important, given that you would be capturing every data point, probably every second or every minute or every day, based on some frequency, you'd be capturing continuously. And whenever you want to forecast the next data point, you need access to the previous data point. For sure. I mean, the time series data, Jan, Feb, March, April, May, June, July, August, September, October. And then if you want to predict for November, you need October data. So it becomes very imperative that you pay utmost attention to the quality of the data and how it is captured. Okay. This is point number one. Point number two is, usually when it comes to time series, we deal with a single variable of interest. If you are forecasting sales, only sales, that will be the key variable. However, people look outwards and try to get additional variables which might impact sales, like probably number of products, or maybe number of footfalls, number of people visiting the store, or number of people accessing the e-commerce portal. If you try to get those additional variables and include those also within your model, and then if you try to build a time series model, then it's called as econometric model. And econometric models are widely preferred. Okay, that's one point. And here there are two things once again to deal with the time series datasets. One is go with your traditional techniques, traditional models which exist. Another is go with the deep learning models. When it comes to traditional models, we have data-driven approaches, model-driven approaches, right? And then you have naive forecast technique, moving average technique, exponential smoothing technique, and bunch of other things. And on the other side, when it comes to deep learning, we have techniques such as LSTM, long short-term memory. You have bidirectional LSTM. We have deep bidirectional LSTM. On similar lines, you have RNN, bidirectional RNN, deep bidirectional RNNs, GRUs, gated recurrent units. And now the new breed of algorithms which are used to forecast are transformer techniques. BERT model from Google, GPT models from OpenAI, right? And OPT, which is from Facebook, and whole lot of algorithms are available now, and the accuracies of which are just skyrocketing. But then we have to bear in mind that the moment we use deep learning, accuracy will be very high because it's going to learn very difficult or wide varied patterns as well. But we need to compromise on the explainability. So that's a call that we need to take. And here also, we have techniques such as auto ARIMA techniques, which are used to automate the various algorithms which are built. And then it's going to give you one set of combinations, hyperparameters, which will give you the best results. So I would say any algorithm that we choose now in the current world, the way the world is enhancing, we need to look out for auto ML techniques, auto EDA techniques, auto pre-processing techniques, because the sooner you complete the project, the better it is for us. Right? So, yep. So these are a few insights from time series standpoint.
Okay. So time series, friends, if you by the excuse me, by the inputs provided by Barney. All right. So time series is like it's not a master's degree or an MS or an MD. It is probably a double or a triple MD that one would require to do to be able to get the gist of thing, because that's like a huge area of work and development and study and activity in itself. Another huge area of activity that I see is in the space of image processing and in the black box techniques, especially in the CNN space. So I'd like Sharath, if you could throw some light on what are the things with reference to CNN at a high level. What is the expectation, etc. Post which, like we said, we'll be moving deeper in subsequent sessions.
Thank you, Nitin. I think I'll give the answer in brief. When we talk about deep learning algorithms and the world of machine learning as such, we have a lot of problems solved in the space of image and video analytics. So CNN actually revolutionized the processing of image data. That's how I would personally see. And from there on, it has never looked back. It's improving. And convolution neural networks of course, to understand this, we need some kind of a basic understanding on how a computer looks at an image. So there's something called as computer vision. These concepts are required. Yeah, sorry about that Diwali special background noise. Happy Diwali, everyone. All right, so coming back to this ELN, right? So as I said, we need to see how images are actually seen from a vision of a computer, right? We have to start from there. And as I said, we will be going in detail for discussing these algorithms step by step. And I mean, image data, right? So we have a lot of readily available pre-trained algorithms which can be used for the problem solving in our case, any business case that we talk about. So it's kind of you take readily available models, use them for your data. Of course, we will have to try and enhance the data that we have. A lot of annotation has to happen, ensure that varied conditions are considered, and we bring the data in for training purpose. We retrain the pre-trained models. This is the basic flow that we generally go ahead with. Retrain the algorithm. And then once the training is completed, we basically take the weights that are obtained, and using those weights, we'll try to predict on new data. Now, accuracy will not be a big problem here. As Bunny said, these algorithms are trying to learn the varied features from our data set. So accuracy is not going to be any problem. But I would definitely want to bring up one point that probably I missed, which is reproducibility of the algorithms. And we will probably discuss more about this in next session. I would definitely want to throw more information on this. So that's with respect to CNN, and I'm just trying to build curiosity here to bring up, right, the important aspects of the machine learning model, model development in an interview perspective. So how would you reproduce the models with same performance? So this is something that we should be discussing more, Nathan. That's my point.
Thank you. Thank you, Sharat. So keeping in the spirit of the theme of the session here, so we are keeping it at a slightly high level, not at a very high level, because we've almost third week into that, a slightly high level. So every week we'll be going down and getting into it. So we wanted to touch base about the various algorithms. We have a lot more algorithms which we have not even mentioned as far as our our discussions have happened this week. So that will be the remainder of this week. We'll be discussing only the names and a little more into that. But before we wrap up for today, we have a request and also something that so among the people who are currently watching, I'm sure you are watching this because you really like and appreciate the efforts that the three of us combining our times together and are doing it. But we are not able to see the the feedback or the kind of response from the participants on that front. We are not able to see the people registered and subscribed to our link increasing. So that is again a little disheartening. I mean, gives an impression that maybe we are not doing our job well. And if we are not doing our job well, let us know. All right. If we are doing our job well, then the numbers should increase. So are you sending out these, the requests to your friends? Are you yourself, all of you have subscribed? Are you spreading the word? All right. So please do that because like I said, we data scientists and educators or trainers thrive on the feedback and thrive on the positivity that the faceless and the anonymous positivity that we get from the audience. That is in terms of this particular channel, we got so many people subscribing. It doesn't matter who. You don't require, a one-on-one kind of thank you so much. Nothing. We just want those. So many people are following. So many people are liking it. That is what we thrive on. That is what motivates us. So please do motivate us. All right. And on that note, I'd like to wrap it up. Diwali still continues in place where I am, place where Sharat is. we've just finished our, the solar eclipse. So things are nice, things are good. And of course, we are still enjoying the hashtag Rishi Sunak. All right. So that is also kind of trending. So in that, let us also trend this particular channel as well. Thank you so much.
Thank you all, friends. Please like, share, and comment. Thank you so much.